Use product and quotient rules to find the derivative of exponential functions with any base. Let's take a look at our first example. So here we want to find f prime of x if f of x is equal to x to the fourth times 5 to the x power. And when we look at this, hopefully we notice that this is going to be the product rule because it's x to the fourth times 5 to the x. And in order to use the product rule, remember, we're going to have to identify our first function, and we're going to have to identify our second function. So the first function will be x to the fourth. The second function will be 5 to the x. So when we come in and we take the derivative, f prime of x, product rule says we take the derivative of the first function, which will be 4x cubed, simple power rule. We're going to leave the second function alone. Then plus the original first function, which is x to the fourth, and then times the derivative of the second function. And the derivative of 5 raised to the x power is going to be 5 to the x times the natural log of 5. And then our last step here is just to simplify, and there's nothing we can really do to simplify except get rid of some of these parentheses. So we're going to have 4x cubed times 5 to the x plus x to the fourth times 5 to the x times the natural log of 5. And there we go. That's all the simplifying we can do here. I mean, technically, if we wanted to, we could factor out an x cubed and a 5 to the x power, but that really doesn't make this any simpler. Moving on, next up we want to find f prime if f of x is equal to 2 raised to the x power of arc cotangent of x. So just like the last one, this one does involve the product rule because we have 2 to the x times arc cotangent. But before we begin, let's quickly review our derivative of arc cotangent. And if we remember, the derivative of arc cotangent is going to be negative 1 over the inside squared plus 1. So we can just keep that in mind when we are going through and using the product rule. So, as always, our first function is 2 raised to the x power, and our second function is arc cotangent. So we'll go ahead and we'll take the derivative. Product rule says take the derivative of the first function, which is 2 to the x times the natural log of 2. We leave the second function alone, and then we add. We leave the first function alone, so just 2 to the x power, but then we have to multiply by the derivative of the second function, and the derivative of arc cotangent, we already remembered, is negative 1 over x squared plus 1. And then from here it's just simplification. So we're going to have 2 to the x times the natural log of 2 times arc cotangent of x. And then since our second term here has a negative sign in front of it, that's going to change this plus sign to be negative. We can then multiply the 2 to the x to be in the numerator and leave the x squared minus 1 in the denominator. And there we have it. There is f prime of x. Now our final example is asking us to determine p prime of 6 to the nearest tenth, where p of x is equal to 2 times 6 to the x power all over 3x to the fifth. So this time we're being asked to find the derivative at a specific point. But before we can find the derivative at a specific point, i.e. 6, we first need to find the general derivative. So that means we are going to be looking for p prime of x. And if we look here, we can see that we are taking 2 times 6 to the x power and dividing it by 3x to the fifth. That means we need to use the quotient rule, and we need to identify both our top and our bottom functions. So we're going to identify the top as being 2 times the quantity 6 to the x power, and our bottom being 3x to the fifth. Quotient rule says we take the derivative of the top function first. But before we do that, let's quickly remember that this 2 in front of the 6x is the coefficient of 6 to the x power. And we know that when we take the derivatives, we can ignore the coefficients. So we're just going to rewrite down the 2 there. And then we're going to multiply that by the derivative of 6 to the x power, which we know is 6 to the x times the natural log of 6. Then quotient rule says we multiply by the bottom, that is untouched. And then quotient rule says we subtract the original top function, which is 2 times 6 to the x power, and multiply that by the derivative of the bottom, which is a simple power rule of 15x squared. Then we're going to divide this whole thing by the denominator, 3x to the fifth, and then we just square it. All right, so now if we wanted to, I guess we could simplify this down a little bit. There is some canceling that we can do, but since we are trying to find the derivative at a specific point, there's really no need to take this any further algebraically. If we want to, we can, or we can just plug in 6 for x right now. So therefore, p prime of 6 is going to equal, let's see, 2 times 6 raised to the 6th power times the natural log of 6. And that's going to be times 3 times 6 to the 5th power. Then minus 2 times 6 raised to the 6th power. And then 15 times 6 squared. And that's all going to be over the quantity 3 times 6 to the 5th squared. All right, so now I'm going to plug each of these pieces into the calculator separately and then combine them together. So my first piece I'm going to plug in the calculator is my first term here. So let's see, we're going to have parentheses 2 times 6 to the 6th power times the natural log of 6 times 3 times 6 to the 5th power. And that's going to give us an answer, or at a value of, let's see, 3900270363. Then I'm going to plug this second one into the calculator. So let's see, parentheses 2 times 6 to the 6th power times 15 times 6 to the 2nd power. And that is going to give us 503888480. And then that's going to all be over 3 times 6 raised to the 5th power, and all of that is squared, giving us a value of 544195584. And now, since we have each individual piece, we can put it all together. So 3900270363 minus 503888480 divided by 544195584. And that is going to give me 7.0744 yada yada yada. But let's remember the problem asks us to round to the nearest tenth. So therefore, our final answer is going to be 7.1. So therefore, the derivative of the function p at x equals 6 is going to be 7.1. And there you have it, using the product and quotient rules to find the derivative of exponential functions with any base.